Hello, this is Avalisha, and today I'm going to show you my project demo. So the project name is IoT Early File Detection using IoT and machine learning. The project contains three parts. One is the hardware code, and second one is the a real-time application that will show the data of real-time fetched by the sensor. And the third part is the machine learning website, which will predict the website on the basis of the data that is collected by the sensor. Right now, let me show you the hardware code. So this is the hardware code written Uno, like Arduino Uno on Uno compiler. This code will basically is the programming of all the sensor like DHT11 sensor, like pressure sensor, like temperature sensor, like rainfall sensor. The all sensor are connected to one single module known as ESP node MCU module. This ESP node MCU module will fetch the data from the sensor, and because ESP node MCU module has an inbuilt Wi-Fi that take all the data and send the data to the Firebase database. I am using a Firebase database because it's a real-time Firebase database. And after that, we will fetch the data from database through a real-time application that will show the weather parameter, right? And I will collect this weather parameter into a CSV file. And then because our machine learning website will predict data in the form of a input in the form of a CSV file, and then we'll predict the prediction and flood prediction at that particular area, right? So, so this is the hardware code, and this is index.h file, which is basically a real-time application. Let me show you the hardware code, right? So all the libraries are included, right? And the SSID, that is the SSID my now, and this is the password of the my Wi-Fi because Node MCU is a has an inbuilt Wi-Fi module, so it requires the SSID and the password to send the data on the Firebase database. So here I'm using a humidity temperature, and this all the things, right? So when I connect my hardware to the port number, like here is the port number and here is the port number, like get board info. Here I'm choosing the a node MCU port, right? But the hardware is not present yet. Uh, we make a hardware and then we connect that hardware to the uh, port number or to the Arduino compiler. And when we upload the hardware code into the node MC module, it will give an IP address of that module, and we will copy that IP address because it will print an IP on the solid CL monitor, and then and after that we will print that IP address and paste into any browser, and that will open a real-time application showing the real-time data, right? So let me compile this. So this is compiling. This is a big code. It takes much time to compile, right? So, and while compiling, I will explain something more into it. So this is the serial.println because this will print on the serial monitor, right? Error receiving, pressure management, all the parameters that it all the parameters measured by the sensors are printed on the serial monitor, as well as the IP of the uh, node MCU so that we can open our real-time application, right? So this is compiling. If any errors occur, it will fail. So here is in the this format. In this format, the values should be printed, right? It is compiling, and it is also print the IP address. So you can see here this it is also print the IP address of the Wi-Fi module. and we simply copy it and paste it in the browser, and then we can access the application or real-time application or the weather station application, right? So let me show you, because it takes so much time, let me show you the application, which application is offered, right? This is index.html application. Let me show you which application is offered. It is compiled. So let me show you the application which is open here. Go to the dashboard, and here is the application, uh, index.html. This is containing HTML, CSS, JavaScript, and bootstrap code. So this will open our real-time application. So this is the application. The date is August 3. This is the real time, and the temperature is 23 degrees centigrade. When we connect the, because the hardware is not connected yet, when we connect the hardware, this application will show the data fetched by the sensor. And the most important part of this application, we can access the data from anywhere, right? If the hardware setup is in the Bihar city, or is in the is on the any river of body in the Bihar city, we can access into the we can access this data from Delhi as well, because we only require the IP of the Node MC module, which is installed onto the hardware module, into the hardware module, right? So temperature here, pressure here, rain here, humidity here. We will collect all this data and put that data into CSV file. And this CSV file will go into the machine learning model. And then we can predict what is the chances of the flood in that particular area, in that particular area. So let me show you where is my, this is my final code of the data, right? So let me open the CD file. This is all the data, right? And here is my VNV. So I will activate source my VNV. Will I will activate the virtual environment, right? And after that, I will run my application, which is class run application. If there is no error, it will give. So here is saying that BSG dot or app.py module lost find the current directory. Okay, so I will export Flask app to app.py or main. Yeah, it is running fine, I think. It will give an IP address, because this IP, so it will give this IP address. This IP is nothing but the address of our website on the local host, right? Let me copy this IP, copy that URL, go to any browser and just paste this URL. Let me paste, and you can see the backend, right? So this is nothing but our machine learning model, right? So this machine learning model of fraud prediction model, it will take a CSV file, and that CSV file will be made by using this data, right? So we'll choose a file. Where is the, let me upload example file here. So here in the final folder, there is a final.data.csv file, right? Let me click here to predict what are the chances in that particular data. So The chances will print on this location. It will. So what are the minimum chances in that particular area, right? So let me click here to predict. Oh, that's fine. It will showing that predicted chances of the flood in your area is are 10%. That's great. And it is using a machine learning or CNN model in the backend, a logistic declaration, support vector machine, and KNN model. And all the efficient algorithms are used in the backend model. So that is all about my project. Thank you very much. Thank you very much. Let me stop it.